as a closed figure formed by 4 segments intersecting at their endpoints. Okay, a parallelogram is a quadrilateral in which opposite sides are parallel. Okay, so example 1, the parallelograms at the right has 4 vertices. So what are the 4 vertices?
N, M, P, Q.
Okay, so those are our 4 vertices. Okay, yes, it's a parallelogram, but how do we name a parallelogram? Does anybody know?
Square.
A square. It says it in part C.
MNPQ.
Very good. So you just name it with the 4 vertices and then the little symbol. Okay, so if you see that in a proof or something, that is parallelogram MNPQ.
Do you have proofs on this?
Lots of them, yeah. Okay, opposite sides for parallelogram MNPQ are, NP is opposite of what?
PQ.
NP is opposite of what?
MQ.
MQ. MN is opposite of
QP.
QP. Okay, opposite angles of parallelogram MNPQ are, angle M is opposite of what?
P.
P. And angle N is opposite
Q.
opposite. Okay, and then the last one, the consecutive angles of MNPQ are blank. What does it mean to be consecutive?
Back to back.
Okay, well, what does that mean?
Next to each other.
Next to each other, on the same segment, okay? So, angle N is consecutive to what?
P, N, M.
Angle M, and it's also consecutive to P. P is consecutive to what?
Q.
Q.
And
And N, but we already have that one, so I'm going to leave it. And then M is consecutive to Q. And that should be all of them. Okay, questions on labeling just the different pieces. Okay, so you're going to have opposite sides, opposite angles, and consecutive angles within your parallelograms. Okay, using MNPQ, what conjectures can you make about the following? Okay, opposite sides are what?
MQ.
Are parallel and what else? Congruent. Okay, so opposite sides of parallelograms are parallel and congruent. What do you think about their opposite angles? Congruent. And last but not least, consecutive angles, so those that are right next to each other, what do you think about those?
Equivalent, congruent.
Supplementary. Okay, let's look at why those are supplementary. Okay, if I turn my paper back over, shh, guys, you've got to quit talking over me. Okay, if these lines are parallel, what do we call these two angles?
Consecutive.
Yes, consecutive. What else? Same side interior angles. And same side interior angles are supplementary. Remember, same side supplementary. Okay, so consecutive angles are supplementary. Okay, so when polygons have more than 3 sides, they have diagonals, and diagonals of parallelograms bisect each other. So that's another property that you have to memorize. Okay, the diagonals of parallelograms bisect each other. Okay, so that brings us to 6 properties of parallelograms. Okay, and they are: opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, okay, and the last thing is the diagonal form 2 congruent triangles. Okay, so those are our 6 properties of parallelograms. Okay, so for example 2, it says complete each statement regarding the parallelogram below. Okay, so if we were to name this parallelogram, you would start by drawing your little symbol, and then what?
D, A, B, C.
Oh, I'm really glad you said it like that. Okay, starting now, the way that you name your shapes truly matters, because it's not just triangles anymore where you can go any order. Okay, because there's 4 pieces, you've got to make sure that you label it in like a clockwise or a counterclockwise order.
A, B, C.
Very good. So you could say C, D, A, B, you could say D, A, B, C, you could say B, C, D, A, you could say A, B, C, D. You could say all those different ways, but you can't go A, C, D, B, or B, A, C, D. Okay, so you have to go in a consistent order. Okay, so I'm just going to go A, B, C, D. Okay, AB is parallel to what?
DC.
DC. DA is congruent to
CB.
CB. CDA is congruent to
A, B, C.
ABC or CBA, it doesn't matter. And DE is congruent to what?
A,
B.
B.
BE. Because your diagonals bisect each other. Okay, so that would mean that AE is congruent to CE. That doesn't always necessarily mean that DE is congruent to AE. They just bisect each other. Okay? Number 3. If ABCD is a parallelogram and angle A equals x degrees and D equals 2x minus 3, find the value of x. So draw your parallelogram. Make sure you label your parallelogram in a clockwise or counterclockwise order. So if A equals x degrees and D equals 2x minus 3, what do you know about angle A and D? They're supplementary. Why? They're consecutive and they're also same side. So consecutive angles. Okay, so you know that x plus 2x minus 3 equals 180. So I have 3x equals 183. And so what does x equal? Questions on example 3? Okay, example 4. X, Y, Z, W is a parallelogram with diagonals X, Z, and Y, W that intersect at point A. If XA is 3 m, and ZA is 5m minus 4, and YW equals 10m, find m. Okay, so start with drawing your parallelogram. So I have X, Y, Z, W. Okay, I want to make sure that I have it set up right. XZ should be a diagonal, and YW should be a diagonal. And they intersect at A. Okay, XA is 3m, ZA is 5m minus 4, and YW is 10m. How could we figure out m? Very good. 3m equals 5m minus 4. They put that 10m there as a decoy to see if you would say 10m equals 3m plus 5m minus 4. The diagonals aren't necessarily congruent. They just bisect each other. Okay, so sometimes they're going to give you extra information that you don't need to test and make sure you know your properties. Okay, so yes, this 3m piece is equal to 5m minus 4. So if I subtract 5m from both sides, I get negative 2m equals negative 4. Divide by negative 2, and m equals 2. Okay, so don't fall for the little tricks. Questions on 4? Okay. 5, 6, and 7, we're solving for our values of x, y, and z. Okay. What do you know about, or which angle could you solve for first? Okay, what is y?
No, it's not 100. It's 80.
How do you know y is 80?
Because because the side that is on like the opposite of y, the side next to it has to be 180 minus 80, which equals 100. Then 100 minus 180 equals 80.
Very good. There's other ways you could have gone about that as well, and I'll talk about it once we find all of our angles. But he's saying that because these two angles right here are consecutive, or on their same side, their sum has to be 180. Okay, and so if that's 100, well, you know 100 and y also have to be 180, which makes y 80 degrees. Okay, what's another angle that we know? Which is what? Also 80y.
Because 100 plus 80 equals 180.
Okay, but what other property other than the consecutive angles? Opposite what? Opposite angles are congruent. Okay, so these are opposite of each other. So, Mason, shh. Okay, so once you know that, you also know that if you were to extend these lines, okay, and this is your transversal, these right here are alternate interior angles. Okay, so x and y had to be congruent as well. And that leaves z to equal what? 100. Because again, opposite angles have to be congruent. Awesome. Okay, moving on to number 6. What's an angle that we know? Z, which is 120. Okay, if you extend some of your lines, it might help you. What other angle do you know?
Y.
How do you know Y?
Interior.
Alternate interior angles. So if you turn your paper, you have alternate sides of the transversal in between the parallel lines. Okay, so you have alternate interior angles. Okay, and what does that leave X to be?
120 plus 35.
Very good. So you have 180 minus 120 minus 35. 25. Questions on 6? Okay. 7. Give me an angle that we know, which is
30.
Y.
Because interior.
Alternate interior angles again. Okay, what else do we know?
Oh, 7, 110.
Z is 110, Y Mason. No.
Because they add up to 180.
They add up to 180, okay, because these two angles right here are supplementary because they form this straight line. Okay, and then how can we figure out Y? How did you get 40, Austin? Was that you? Yeah. 110 plus 30 subtracted from 180. And that leaves you with 40 degrees. Questions on that? Okay, with your table, do example 8.
It tells you.
Or 18. Oh, yeah. That line right there. What? It's on one line only. A is not the whole line. A is only the line. Yeah. It tells you the word problem.
So, you know, W angle W and angle Y are the same, both angle 49.
Yeah.
And all these angles have to add up to 180. Oh, you just add it up to 90 degrees. 180 minus 180 is 45.
Divide by 2.
Oh, and because it's,
So what we have here, 49 times 2.
where is my
Which equals 98.
Diagonal bisects. angles.
Oh, it's 11.
I don't know.
What? No, you have to use equal to 11. Well, look at X.
Okay, what was A? 15. How did you know A was 15?
The bisector figure.
Because the diagonals bisect each other. Okay, what is B?
49 degrees.
49 degrees. C?
11.
11. And D?
How do you get? You add angle y and W. Why would you add 80?
Yeah, that's what I did. I added
131. How'd you guys get 131?
That's what I thought. Y'all already say it. Y'all know.
Pardon? Because X and Y are supplementary. They're consecutive angles.
Oh, so 850 minus 180?
What?
Oh.
You see it now?
Yeah.
Okay. Somebody say no.
No.
So, for letter B, you guys found that ZWX is 49 degrees. Okay. These two angles right here are supplementary because they're consecutive angles. So if this is 49 degrees, this angle here is 180 minus 49. And that's 131. Okay, on the back of your pink sheet, turn it over so I can write a few things that is going to help us before we start the proof. Okay. So, in order to prove a quadrilateral is a parallelogram, okay, you have to prove one of these four things. Okay, number one, you have to prove that both pairs of opposite sides are parallel. Huh?
Oh, what does it say after orange?
Is a
Is it parallelogram?
It's just the shape of a parallelogram. Y'all should probably move up. There's a lot of empty seats.
In order to prove that quadrilateral is a parallelogram. And then I can.
Okay, number one. Mason. Yes, you were. I'm pretty sure the last thing you said, and I couldn't see from there. Okay, number one. Prove that both pairs of opposite sides are parallel. Okay, that's one way you can prove it's a parallelogram. Second way you can prove that it's a parallelogram is prove that both pairs of opposite sides are congruent. Okay, the third way you can prove that it's a parallelogram is that one pair of opposite sides is both congruent and parallel. And then last but not least, the fourth way you can prove that a quadrilateral is a parallelogram is to prove that the diagonals bisect each other. once you have all those written down, just put them to the side so that you can reference them when we're doing the proof. Okay. Proof number 1. Given angle 2 is congruent to angle 4 and AB is congruent to CD, prove that this is a parallelogram. Okay, so we have statements on the left, reasons on the right. Always start with the given. Okay, so 2 is congruent to 4, and AB is congruent to CD. So what else do we know?
1 and 3 are congruent.
How do you know 1 and 3 are congruent?
Because they're the same thing, alternate.
You don't know any of those sides are parallel.
Oh.
Angle 1 and 3 are congruent to the opposite interior.
You don't know that those sides are parallel.
B, C,
Oh yeah.
Yes, but that won't help you. No more freebies.
I have no idea.
Test your vocab from a long time ago.
Translate.
You need to use 2 and 4. I'll give you that hint.
Oh, 2 and 3 are because on the same line, so they're gonna be out of 180.
It has something to do with alternate interiors.
2 and 4 alternate.
I already gave you that.
So, Austin, I'll pick your brain then. So 2 and 4 are alternate interior angles. Yes. So what does that tell you about some of your segments?
You add to 180.
So if these are alternate interior angles, which sides have to be parallel in order for those to be alternate interior angles? BA and CD. So if BA and CD have to be parallel, oh, not congruent, parallel. Why are they parallel?
Because of the alternate interior.
1 and 4 are...
It's alternate interior what theorem?
Alternate interior and theorem. Because it makes an end.
Start with a C.
Converse.
Converse theorem. Alternate interior angle converse theorem. Okay, so think way back. Okay, when we were first discussing same side interior, same side exterior, alternate exterior, and corresponding angles, that was all in relation to 2 parallel lines cut by a transversal. Then that following day, we looked at all the converse theorems and how if we do have those angle relationships, then those lines have to be parallel. Okay, so we worked one way one day, and then we did the converse the next day. So if you have parallel lines, then you can prove alternate interior, alternate exterior, and all that good stuff. If you have alternate interior, exterior, corresponding and all of that, you can prove that the lines are parallel by the converse theorem. Okay? So yes, you'll need to know those things. Okay, so now I've marked my picture. We know that AB is congruent to CD and AB is parallel to CD. So looking at your pink sheet, where do we need to go next?
Prove ABCD is parallelogram.
Okay, ABCD is a parallelogram, and why is that?
Because one pair of opposite sides is congruent and parallel.
Very good. Parallelogram. That's number 3, I think. And you're done. So that was just a 3-step proof. Alright, this one will be interesting. Okay, for number 10, we are proving the following theorem, or the following property that states that if diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we are proving number 4. Okay, so we're not going to be using our parallelogram things to get there. We're going to have to use other methods to prove it's a parallelogram. Okay, so the first thing is our statement, or our given. Okay, if you guys want to write all that, great. I'm not going to for the sake of the room, so I'm just going to write given. Okay, so give me something in that picture that you guys know.
LA and AN are congruent.
LA and AN are congruent, yes.
And DA and AL are congruent. AI and congruent.
Yes.
So you can prove that opposite triangles are congruent.
Okay, one step at a time, but yes.
And
Hold on, but what's the reason for LA and AN congruent and DA and AI? Very good. Definition of bisect. Okay, so I'm going to mark my pictures as we figure this stuff out. Remember that LA is not congruent to AI. LA is congruent to AN. It bisects the segment. They don't necessarily mean they are congruent. Peyton, wake up. Okay, so I've marked my picture. What else do we know?
DA and AI.
Do what?
DA.
I wrote that one.
Okay, so you can prove that a triangle LAI and NAD are congruent. SAS.
We don't have any angles.
Oh, it's vertical. Ooh.
Vertical angles. What vertical angles?
LAI and NAD.
LAI is congruent to NAD
Yes.
because of vertical angles.
So the two triangles are congruent.
There you go, James.
So
Vertical.
LI and ND are congruent.
You said LIA and NAD?
Yes.
LIA and DA. And why is that, James?
SAS.
SAS. Okay, and then where do you go from there? So now we have two little triangles that are congruent.
You can prove the side LI and ND are congruent.
LI and ND are congruent. Why is that? Very good.
And the same as other two triangles.
Okay, and the same thing in the other two triangles, but where are you going to get your angle in your other two triangles?
That's LAD.
LAD. And that would be because of vertical angles. Which makes which triangles congruent?
LAD and IA.
And why is that?
SAS.
Solution, you can go that far.
Yes. Okay. And then what, James?
And then you got LD congruent to NI.
LD is congruent to NI. Why? Oops. Okay. Anything yet on our pink sheet?
And then you got 4 congruent sides.
And then you've not necessarily 4 congruent sides, but what?
Two pairs of.
2 pairs of congruent sides. Okay. So you would have that the quad LI and D is a parallelogram. And the reason being is number 2 on your pink sheet. I'm running out of room, so I can't write it. But number 2 on your pink sheet, because it says prove both pairs of opposite sides are congruent. Had you want to combine steps, you could have, like, so with the vertical angles, you could have combined 3 and 6. And you could have combined 4 and 7, and then you could have combined 5 and 8 to make it like a 6-step proof rather than 9. But if you are somebody who needs to write out every step, that is A-okay. But for the sake of room, sometimes it's easier to consolidate. Questions on the proofs?
Is this gonna be like what our test
Yes.
proofs are?
Yes. Okay, with your table, use your pink sheet, and you're looking down that first column under parallelograms, okay? And you are checking off which properties apply to parallelograms, okay? Go. I'm going to give you a minute. Go down and check off which properties apply to parallelograms.
It's right here.
Consecutive sides are congruent, that's true.
Diagonals, bisects, opposite angles.
Consecutive sides are congruent. No, they have to be.
Wait.
Two for each. Where?
Yeah. So is that true? Wait, are the diagonals congruent?
I like you and you like that.
You should only have 6 check marks.
1, 2, 3, 4, 5, 6.
Acid has to be.
I don't think the last one is right. It says it on here.
I won't be here Thursday or Friday to retest, so I could come in next period if emails push come back. I could come in tomorrow at lunch.
Tomorrow at lunch would be better.
Okay.
Perfect. B block.
Okay, should I show you my
When we work on the homework, yeah. Alright, are opposite sides parallel?
Yes.
Are opposite sides congruent?
Yes.
Are all sides congruent? No. Are consecutive sides are congruent? No. Are opposite angles congruent? Yes. Are opposite angles supplementary? No. Are consecutive angles supplementary? Are consecutive angles congruent?
No.
All angles are right angles.
No.
Diagonals are congruent.
No.
Diagonals are perpendicular.
No.
Diagonals bisect each other.
Yes.
Diagonals bisect opposite angles.
No.
Diagonals form 2 congruent triangles.
Yes.
So those are the 6 things. Okay. I handed out the homework